Good morning. Happy daylight savings time. I prepared this video to help you with homework 6 acid-base problems, and I'm going to start by showing you where the files are. Acid-base MATLAB.zip was located in Canvas. When you download that, make sure you get all of the files within that into a single folder, as I've done here. I have them in a folder called acid-base, and the files you need are titration plot, solver, main.m, log.cph, get output, get input, distribution plot, and beaker plot. I've loaded main.m into my workspace, and I'm going to run that, as that will run all of the other codes. So the first thing you notice is I can select the acid-base system I want to work with. I can choose a weak monoprotic acid, such as HA, a weak diprotic acid, such as H2A. I can choose the salt of a monoprotic system, such as NaA, the salt of a diprotic system, such as either NaHA or Na2A. I can even run an acid and base from the same system, or an acid and base from two different acid-base systems. And I can do that also for the diprotic system. So I'm going to start out by choosing a weak monoprotic acid. I select OK. And at this point I'm asked to enter a species. I can leave it generically as HA, or I can put in one of the acids we've worked with, such as HOCl. Most important parts are entering the total concentration. Here I've entered 10 to the minus 4 molar, and the pKa, which is 7.5 for the HOCl system. I select OK, and now I select what I want to solve, what programs I want to run. I want to run the solver. I'd like to see the beaker diagram, the distribution diagram, the log.cph diagram, and the log.cph diagram where we've plotted also the left-hand side and right-hand side of the charge balance. So once I've selected those, I can hit OK. And now I can select species that I want to show up in the beaker. If you're in Windows, you should hold the Control key down to select more, and in Mac, the Command key. Notice we've already picked H+, H2O, and OH-, which are in every system. So holding down the Control key, I'm also going to pick HOCl and OCl-. I'll hit OK, and the program begins to run. As you can see, my beaker diagram shows HOCl added to the water, and the species HOCl, H+, H2O, OCl-, and OH. These are the species that will exist in this system at equilibrium. You can also notice that if I move this figure aside, or blow it up, if I move this figure aside, we get the acid-base distribution diagram. Okay? Here you can see that at the pKa of 7.5, alpha naught and alpha 1 are both equal to 0.5, indicating that the acid and base have equal concentrations. At low pH, alpha naught, corresponding to the acid, dominates, and above the pKa, alpha 1, corresponding to the base, dominates. Okay. Closing this figure, the next figure that you see is a log.cph diagram. If I expand that, you can see the different species that we've plotted. Here's log of H+, log of OH-, log of HOCl in yellow, and log of OCl- in purple. Okay. Finally, the last plot shows the same log.cph diagram with the log of the left-hand side of our charge balance, or log of H+, and the line for the log. The right-hand side, which is corresponds to OH minus plus OCl minus. Notice that they cross at about pH 5.75. And if we close this, or at least make it smaller, you can see that this corresponds to the pH that was found by the solver. So that being the case, we see we get correspondence between our log CPH diagram and the solver solution. Okay. The other thing you notice is that in the solver you get the log of the other unknown species, log of OH minus, log of HA, log of A minus, all of which you can read off of the log CPH diagram by selecting the appropriate line at the pH of 5.75 and reading to the left. So you note that log of HOCl is essentially log of CT, or 10 to the minus 4. Log of OH and log of OH and log of A minus can also be found, again, by reading off to the right. Those values correspond to what we see for log of OH, log of HA, and log of A minus in the solver. Okay, so we've completed that problem. We can move on and run the program again, this time picking the base. So we're going to add the monoprotic salt, and let's just go with the default here of sodium cyanide at a concentration of 10 to the minus 3 and a pKa of 9.21. Again, we select OK, holding on our Shift key. We can select all of these, or we can select each individually. Solver, beaker, distribution diagram, log CPH, and log CPH diagram with the solution. We hit OK. Again, OH, H2O, and H plus show up. Holding the control key, we can add HCN and CN minus. We hit OK, and now our solver solution and our 4 plots appear. Sodium cyanide completely dissociates, so it does not appear at equilibrium in our solution, and the species we have are CN minus, HCN, H plus, H2O, and OH minus. Okay. Moving on to the distribution diagram, what we note is that in the distribution diagram, again, at alpha equals 0.5, we are at the pKa. Notice that the curve has shifted from the previous acid that had a pK of 7.5. This one corresponds to our 9.21 pKa. And again, the acid dominates at low pH, the base dominates at high pH. The next plot we see is the log CPH diagram. Again, we can see all the different species, log of H plus, log of OH minus, the log of HCN, and the log of CN minus. And then finally, in this case, when we plot the log of the left-hand side and the right-hand side, okay, we see that we are in fact not using the charge balance, but we have substituted for the salt into the charge balance. So we have log of OH minus on the right-hand side and log of H plus HCN for the log of the left-hand side. And we see that those cross each other at about 10.05. And if we minimize this, you can see that that corresponds to the pH found by the solver. And again, we get the concentrations of all the other species, including the log of the sodium concentration of -3. And again, we can read all of these concentrations off of the graph. So we've solved both the acid and the base problems for you. If you have any questions, please be sure to come to office hours, to send me a text, or get hold of one of the TAs. Thanks for your attention, and have a great day.